Welcome to our third module, which is going to be looking at science and ethics, and our first unit within this module, which is going to focus on ethics and values. And I find this particular module a really interesting one, and I certainly hope you do as well, because it brings up a lot of issues that you may be familiar with and perhaps didn't know as much about. So why study ethics? You're probably thinking right now, what does ethics have to do with science? And what role should ethics play in the science classroom? And even that term ethics, what's your understanding of the term? It's a really loaded term. It has a number of different meanings to different people. So we're going to explore that a little bit more in some more detail. So why study ethics in the science classroom? Well, we do know, and if you think back to our Nature of Science module, we know that ethics and values play a significant role in science, and ignoring this fact will diminish a student's comprehension of the true nature of the scientific enterprise. So that's really important because we do know that science doesn't exist in isolation. It's part of a broader context that involves ethics, values, philosophy, religion can have impacts, political, economic, a range of different factors. It's interesting though, because this is not an assumption that's accepted and appreciated by most secondary school students or by their teachers. So we find, particularly in the high school context, that teachers tend to be disciplinarians. They tend to teach their discipline. So they're a science teacher, or they're a maths teacher, or they're a history teacher, and they have their own, sometimes can be quite a narrow view of outside factors that actually impact on their own disciplines. So when asked about the connection between ethics and science, many science teachers will make reference to issues such as scientific fraud and plagiarism that occasionally make dramatic headlines. And they view this behaviour as the exception rather than the rule, and profess a belief that science is for the most part an objective and value-free activity practiced by honest, moral individuals. Now, that's obviously what we would hope for, but as you'll see as we go through this unit, there have been a number of exceptions to this rule, and often we teach a sort of cleaned up version of our disciplines. So it's important our students get some sense of the fact that sometimes it's not as cleaned up as what they may think. So when students are taught that scientists are individuals who are subject to the same social pressures and temptations as the rest of society, they're more likely to identify with scientists. It's a really important point to make, because if we want more of our students to go on and continue to take science throughout high school, they need to know that there's some connection there, that they can see the relevance to themselves. The powerful methods that science offers for seeking knowledge about the universe then become personally accessible rather than a set of tools available only to the members of the scientific elite. And that's so important. So our sort of focus on scientific literacy and science for all is a really important factor here. And this is an area where ethics can give you those tools to allow students to see the connections. So the introduction of ethical issues in the school science curriculum is important. And although most students will not become scientists, all students will need to participate as citizens in making informed choices about the uses of science. So this is a key point. It's really important, is that we know the vast majority of our students won't go on to a tertiary science-based course, but we do know that a number of issues can come up in their lives where it's important that they make evidence-based decisions and that they have some grounding in science. So if we had to define ethics, how would we do it? So here's some different ways you can think about it. So ethics is concerned with right and wrong, good or bad, fair or unfair, responsible or irresponsible, obligatory or permissible, praiseworthy or blameworthy. So usually we present a really dichotomous view of ethics, in that ethics tells us if it's good or it's bad. But importantly, like most concepts, there's lots of in-betweens. So on the one hand, it draws strength from our social environment, established practices, law, religion, and individual conscience. And on the other, it critically assesses each of these sources of strength. So it's quite a complex phenomenon. It can be controversial, and importantly, it defies a concise, clear definition. So we're going to have a look at some ethical issues focusing in on scientific research, or the practice of science. And we do know that ethical issues are prevalent throughout all aspects of scientific research, from the very beginning, where we choose our goals that we want to pursue, right through to how we present our findings. And for many students that have previously done this course, these aspects that I'm going to talk about in the next few slides are quite new to them. We always just see that sort of finished form science and the great scientific discovery that we've made, or the great health benefits of some new drug. But really, throughout each stage of scientific research, there are opportunities for unethical behaviour. And we're going to look at these in more detail. So I'm going to start you off with just a small clip to begin.
The problem of scientific fraud has been reaching epidemic proportions in recent years, with increasing numbers of retracted papers in scientific journals. There's even a blog called Retraction Watch that keeps tabs on these things. In my recent conversation with Ron Bailey, Reason Magazine's fine science writer, I asked him about what he thinks is behind all this.
Well, the increase was substantial, and mostly, what they found is that 70% of the papers that were withdrawn over the last 30 years or so turned out to be fraudulent. And that was what shocked them.
Not just mistaken,
not mistaken, but fraudulent. That the data was obviously clearly made up, or the results were tweaked with in some way or other. And the problem that you have is probably there's a huge amount of competition inside the field right now, and you basically try your best to attract grants your way. So that's what you're doing. You're tweaking results in order to get something really interesting, so that more grants will come your way. The problem I find, though, is a deeper problem, though, is the stuff that a epidemiologist named Ioannidis has come up with. It basically looks at the data, and his conclusion, a really brilliant article, is that most scientific results reported in journals are false. Just false. And by what that he means, essentially, that not been replicated, that they are, the effects, especially in epidemiology, that they are trying to find are so tiny that it would be almost impossible to replicate them in any case. And so basically, we're not getting a lot of extra information out of this process. And again, the reason that that he would argue these things are false is not fraud so much, because they're actually playing the techniques the fair way, but that the effects they're finding are so small that essentially people are trying to publish whatever they can in order to get more grants. And so they'll just publish anything. Now, there was an even worse study, in my opinion, came out recently, about 6 months ago, where a couple of researchers that work for biotech companies were looking for cancer targets. So they were looking through the literature, the peer-reviewed literature, to find targets for new drugs for cancer. And so they tried to replicate the 50 most cited papers in this area. And they discovered only 7, I think, of them were actually replicable. Oh. And again, what has happened, in one example, they talked to one of the lead authors of one of the major papers, and the guy said, well, we did 6 experiments and we only reported 1, the other 5 failed. And this is not good.
So, I mean, is it, I'm sort of amazed here, is it too strong to say that we might have better science if we had less science?
I think that is too strong to say. There are some techniques that are coming along now. I can't remember the name, but there's a company out there that will now offer the following. It's basically, if you set aside some money in your study, they will replicate your study. And this way, they will be able, and they'll report what they find. And if it is replicable, if they can't replicate it, then that gives it a much stronger sense of being the case. Right. And so that would be a good thing. So there's some institutional things we might actually try to do with that line.
What we need, in addition to the legendary Journal of Irreproducible Results, we need a Journal of Negative Results.
We certainly do.
Right. Thanks, Ron.
Thank you.
Okay, so I hope you found that quite interesting, actually. Most people find it quite shocking to think about the fact that things can actually be retracted from lead journals, and that's happened, in our top journals such as Nature, Science, The Lancet. It happens. It doesn't get a lot of publicity, but it does happen. And it's not so much even that the scientists are trying to fake their results, is that a lot of the time they're choosing what they report. Out of a large data set, they can pick and choose certain aspects which obviously align with their goals, whilst ignoring other information. And the other part about not being able to replicate or repeat things is an important issue too. So let's have a look. So the first part of any scientific research is choosing the goal for the research. So here's some questions that bring up ethical issues. So you may have heard of the sort of big science projects like the Human Genome Project, the Particle Accelerator projects, which cost billions of dollars. These are the ones that get funded by governments and different organisations. Should they be funded over a broader variety of smaller scientific endeavours? So who chooses? How do we decide what gets funded? Because as scientists, and myself working within research and working within funding and trying to gain sort of grants for projects, how do we decide what's important? How do we decide what we put our money behind? Because clearly if the money's not behind the endeavour doesn't happen. So, who makes those decisions? So that's an important question. So, for example, from 1980 to 2011, the US committed a significant fraction of the federal research budget to the Space Shuttle program. So some of you who are a little older will remember the Space Shuttle program and how much media coverage that got, and also, more importantly, how much funding that got. So, and that funding, there's only a certain pool of money. So decisions have to be made as to how that money's spent. So a large portion was attributed to the Space Shuttle program at the expense of other large appropriations of money for the advancement of knowledge in fields such as medicine, agriculture, and other fields of technology that had a direct bearing on human welfare. So a lot of opponents of this Space Shuttle program funding were saying, well, how is this advancing humankind? Or are we just in, a competition with, Russia as to have better technological development? So today, with an increasing fraction of research being funded by industry, the constraints imposed by corporate interests on the choice of research projects or on the direction of research is becoming an increasingly significant ethical issue. So we don't just have government funding now that is significant, we have private corporations that fund different projects. And we do know historically funding that went in from the sugar industry in the US in particular had a very strong influence on the amount of sugar-based products that entered the US market. So these are all really important ethical issues. So it's not that we're just talking about the technologies, we're actually talking about how we direct funding to increase research in particular areas and also to promote that research. The methods that we use. Again, if you're a little older, most of you wouldn't have even been born in the 1970s, but in the 70s it was a hot topic, was animal rights, because back in that era we could do a lot more things with animals using them as subjects than we can now. And so this has been something where it's been a very good thing, in that heightened public concern about animals as research subjects resulting from the animal rights movement beginning in the 1970s is an issue that's familiar. Well, it's familiar to me and many biology teachers that are probably reaching retirement age. So the deletion of experiments using animals in school science laboratories due to moral objections by teachers, students, parents, or the community is now commonplace. So if you ever do teach science in high school, there's not many things you can do now compared to what you could a long time ago to do with testing on animals. And in most cases, that's a very good thing. So that's where ethical concerns have had a very good outcome. But interestingly, one that's more topical now is the use of a placebo. So if you're not familiar with that word, and some people think it refers to placentas or something to do with fetuses or unborn children, a placebo is something quite different. So many drug trials now, and you'll even see, you'll sometimes get invitations from Griffith to participate in different research projects. And within that suite of projects, sometimes there are those that involve being involved in a trial. And what a placebo is that if you want to do a controlled trial, you need to have one group of participants who have the actual drug, for instance, they're testing a drug, and then you have another group that have what we call a placebo. It's like a sugar pill. So it's actually the people take the pill thinking that it's the drug, but actually it will do nothing. It's a sugar pill. So that's to control for other variables. So that we can have results which we can replicate and that are reliable. But importantly, there are ethical issues because if someone signs up for a trial and they end up being the placebo group, we could potentially be withholding treatment for serious illnesses, right? So say it's a cancer drug. So there's other sort of issues involved there, like can we really have a control group? Is that ethical? Standards of proof and the dissemination of findings. So how much evidence must a scientist accumulate before announcing his or her findings? This is a really important key issue because, and it relates to the video a little bit, is that when's enough? When is enough to say, I feel confident that I can say that the evidence suggests that this drug is the best one, or, that, we found a great solution for environmental pollution. What is the level? And unfortunately, ethically, personal factors and primarily ones relating to the need to publish first in order to advance a scientist's career may tempt them to exaggerate, number one, the certainty of their results, and number two, how quickly they release them. So positive results are often rewarded by increased fundings by research sponsors, and this again increases the temptation to report things early. So in most cases, the science establishment scorns the scientist who chooses to announce his or her findings via the public media before they have been published in a peer-reviewed journal. So for scientists, the gold standard for recognition of their findings is peer-reviewed science journals. So when we say peer review, it means that the journal article gets submitted to a journal which has an editorial board full of experts in the field that do similar work or that are very familiar with the work. And what happens is the journal article is usually blinded, and by that we mean all the identifying information is taken away, such as the scientist's name, the group they're associated with, so that it can get a more neutral judgment on it without going, oh, I don't like Professor Brown's work. So, and usually that would go to 2 to 3 experts in the field, and they will make an independent judgment on the quality of the article and the evidence. So the media emphasis on values such as the novel and spectacular. So we all know media outlets want to know something that's different or interesting to the general public. So there's a real sort of, desire to have those interesting novel results. So this distorts science in that scientists think, well, I need a better media profile too. That's an important part of being a scientist. So all of those are potential ethical issues for scientists. The control of scientific misinformation. So scientists have a duty to control and suppress scientific misinformation. This obligation extends to preventing erroneous research findings from misleading their colleagues, and perhaps more urgently to protect against the danger that false results may endanger the health or welfare of the public. So what that means is we don't want to put findings out there that could potentially lead to, dangerous results for people, particularly in the medical field. And the pharmaceutical industry is really the key culprit here for sometimes doing that. And if you've ever traveled to the United States and turned on free-to-air TV, you will notice the very high influx of drug company ads over there. So it's a huge industry where the pharmaceutical companies are trying to push their products to be the sort of magic pill to fix a whole range of diseases. So I'm going to show you a short clip here, someone's sort of funny take on these misleading advertisements.
Well, it looks like the big pharmaceutical company Merck has been caught yet again fudging science. That's right, the headlines are now talking about the drug Vytorin and the clinical trials that look like they've been fudged by Merck and Schering-Plough in order to create the outcome they wanted to see. How did they do it? Well, they collected all the data from the study spanning several years, and then after the fact, they decided to change what they were measuring in the first place. It's a great way to basically commit scientific fraud and get the results that you want to see so you can convince the FDA your drug is effective and convince doctors that it works and convince people to buy the drug. even though in reality it may not work at all, or it may not even be safe. So I thought, let's do something interesting for a change. Let's take an existing ad by Merck for the drug Vytorin, and let's tell the truth as a narrative audio track on top of the ad. So what follows next is my take. It's a satire, so don't take it too seriously, but it's my take on the drug Vytorin, brought to you by Merck. Check it out.
Cholesterol. We want to convince you it's a disease. We convinced your grandpa it's a disease, but he's not too bright. He eats a lot of red meat. We also convinced your aunt it's a disease, and now we want to convince you to buy Vytorin, because it's a drug that makes us a lot of money. We want you to believe that high cholesterol is caused by things you don't control, like your genes, so you can eat all the ice cream you want and not have to think about how bad it is for your heart. We have no idea if Vytorin actually lowers cholesterol better than Lipitor or Crestor, so we designed a clinical trial to test it. And then we changed the design of the trial after it was done in order to make the outcome fit the data. Nobody really knows if Vytorin is safe or effective, but with enough scientific fraud, we can sure make it look like it is. It's all part of our commitment to selling more drugs to people just like you. Vytorin, the cholesterol drug that redefines science to mean whatever we want.
Okay, did you like that? Remember, that was my take on telling the truth about this drug Vytorin. This is what we find in big pharma today. We find pharmaceuticals whose benefits are greatly over-exaggerated in advertisements, while their side effects are minimized. In fact, drug companies often commit scientific fraud. They conduct numerous clinical trials, and then they cherry-pick the ones that they want the FDA to see, and they bury the rest. This is business as usual in big pharma today, and this is why medicine is so dangerous. It's not based on good hard science. It's not what the FDA calls the gold standard of scientific evidence. It's nothing of the kind. It's basically, in my opinion, scientific fraud. And these companies that are involved in these kinds of clinical shenanigans are, in fact, I believe, engaged in widespread fraud. They've been engaged in price-fixing fraud. They've been sued by 39 different states for price fixing. They've been caught bilking Medicare out of millions of dollars. They've been caught intimidating scientists and suppressing bad studies that they didn't want the public to see. The list just goes on and on. This is an industry that's steeped in corruption and scientific fraud. Now, so don't believe these television ads that you see. The FDA doesn't even review or approve the ads before they run on the air. There's no requirement that an ad tell the truth before it can be aired on television or put in a magazine. No requirement whatsoever. So don't think that ads for pharmaceuticals are good sources of accurate information about the risks or the benefits of those pharmaceuticals. More often than not, it's an ad full of exaggerations based on scientific fraud. That's the way I see it. Thanks for watching. I'm Mike Adams, the Health Ranger for NewsTarget.com.
Well, I hope you found that interesting and quite amusing, but really it highlights some really important issues about what we see in the media. And also, if we've never been aware of any of these issues, we just accept it. We look at it, it's a quick fix, and all of those issues that he brought up are real and they can potentially impact on the general public. So they're very important issues. So the final one is allocation of credit for scientific research achievements. Now this is really interesting because again it brings back that human aspect of science in that for obvious reasons scientists are no less interested than those in any other field of endeavour in receiving appropriate credit for their work. So scientists are human. They enter their professions as anyone else does, a business person or an author or an actor or a doctor or someone who works in a factory. They want to receive credit for what they do. They want to be recognised in their field for being, potentially a leader in their field or an expert. So the agreement by the international scientific community to give credit to the scientist or scientists whose report of a discovery is first submitted to an appropriate journal has provided a means for resolving most but not all of such disputes. So for a scientist, basically, particularly if they're working in a biomedical field or in physics or chemistry related field, if they discover something, the standard that they set, the scientific community sets, is that they need to be the first person or the first group to have that particular study reported in a reputable journal. So it's gone through the review process and it's been published and announces the findings. But interestingly, so in 1983, 2 research groups simultaneously declared they had discovered the virus that caused AIDS and announced their findings independently in the same issue of the prestigious journal Science. Okay, so this one was a case where we know all around the world, when, particularly in the 80s, when AIDS was such a topical issue and we didn't know a lot about it, clearly that set the agenda for different research groups in different countries to start working towards a cure or the identification of what causes AIDS. So a number of groups at the same time were all furiously working towards identifying this virus. And so with these 2 groups submitting at the same time, clearly being probably reviewed by the same group of scientists, they enabled both groups to publish their findings in that same issue of the journal. Since different research groups frequently make nearly simultaneous independent discoveries of the same scientific result or phenomenon, the question arises as to the ethical justification of giving all of the credit to the one who just happens to be the first to submit the results for publication. So there you can see again that point we made about this, publish or perish, or this race to publish, and how that can bring in ethical issues in that scientists know they need to be first. So what does that mean that they might skip over or, play down when they're trying to get to that end result? So after some controversy, both research groups in that AIDS related case were recognised as co-discoverers of the virus. So you can actually Google it and read about the whole controversy. It's quite interesting. Another source of disputes concerns credit for research ideas and ownership of intellectual property is the actual peer review process itself. So what that means, and I was sort of talking about earlier, when a scientist wants to report on the discovery of something or some important findings, they basically submit their paper to a journal which sends the paper out to a range of reviewers. And what happens there is, whilst that paper is under review, those 3 people actually have access to this important information that's never been published. And what can happen is that the reviewers of that paper can then try and replicate those findings and perhaps try and publish their results before this paper gets through the review process. So the review process can be lengthy. So the National Science Foundation in the United States reports that accusations that a peer reviewer appropriated an experimental or theoretical idea or result from a proposal or paper he or she was sent to evaluate is the largest category of scientific misconduct complaints that it receives. So whilst that paper is under review, there's an embargo on it. It's not for release. It's not able to be taken and the ideas taken by other people, but that's a very large source of fraudulent activity. So importantly, the number of such serious accusations is only a very small fraction of all the proposals and papers that are reviewed. So even though it's a small fraction, it's the biggest source of complaints. All very important. I like this one down here. No, it's my wife's turn to be the first author on your paper. And that's not actually really a joke, because working in research, the issue of authorship as well, again, that whole idea of scientists wanting to receive credit. So if you're a PhD student working on a project, in most cases, there's a requirement to have your supervisor's name on the paper. So there's lots of issues there, or potential issues. So what questions should scientists ask before conducting research studies? So the first one, what are the consequences of my research? Will my results positively impact the field? So this one really focuses a lot on those pharmaceuticals. Is it worth it? So ethically, is it worth it? Am I actually engaging in a practice that's going to be better for humanity or potentially worse? The second one, what are the economic considerations? How much is this research going to cost? Think back to the space shuttle program. Was that the best use of the money at the time? Is it worth it? The third one, are the legal costs too high? What are the laws? Even if we can afford it, is it legal? So issues like human cloning or any kind of cloning, are we potentially, opening up this whole bag of bad ideas, so we have to think about, legally, is this actual research going to benefit humankind? Potentially, are there going to be legal issues? Is it worth it? What about moral principles? Is it right? Does the majority vote rule? What does humanity think about it? So some of the, the biological research projects that are happening, and we're going to look at one in detail about using stem cells. Is it worth it? Morally, is it right? So this is scientists. We're saying scientists should ask these things too. They shouldn't just carry out their research. They should think about all these ethical considerations. So considering the information presented in the previous slides, how aware were you that scientific research encompasses the issues presented? Now, for many of you, I think some of it was quite new. You might be thinking, wow, I just never had thought of that before. What could you do as a teacher of science to ensure your students are aware of the competing influences in scientific research? So have a think about that. Think about it in the primary context, and also if you were teaching into the junior secondary. And I'd love for you to share your views on the discussion board about these issues.